Virtualization Basics. What is the purpose of a virtual machine or a VM? The purpose is to run another operating system or an application internally on a hosting platform. So you might have a regular PC computer, and that might be running Windows 8.1 or Windows 10 or what have you. But inside of that, you could run the virtual machine, a separate operating system that is stored as a file, as a virtual machine on the computer, on the hosting computer. And these virtual machines are known as guests. You might have wished in the past that you had a couple extra computers lying around so that you could run additional versions of Windows and run Linux and maybe a Windows server. With virtual software, with virtualization and virtual workstations, you can do this. And you do this with virtual machine manager software, such as Hyper-V or VirtualBox or VMware. And remember the two types. You've got the type 1, which is native, and that means that the hypervisor or the virtual machine manager runs directly on the host computer's hardware. That's also known as bare metal. And you've got type 2. That type 2 hypervisor or virtual machine manager is one that runs inside of the operating system. And so guests run within that hypervisor instead of directly on the bare metal, directly on the hardware. So type 2 is not going to be as quick, but it'll usually be cheaper, if not free, and a little bit of an easier solution. But if you're in a high-tech situation, you want to go with the type 1. Resource requirements. You have to make sure that the system that will host the virtual machine manager software has the right virtualization extensions. So you need to make sure that you have the extensions for the CPU, and for Intel that's VTX, and for AMD CPUs that's AMD-V. Those need to be enabled in the firmware within your BIOS or UEFI. And most new UEFI systems have this. Also, you have virtualization extensions for the chipset. For Intel, that's VTD and VTC. VTD is for input-output memory management, and VTC is for network virtualization. And on the AMD side, for the chipset, you have the AMD-VI extension. So you want to make sure that those are enabled in the firmware. Now, different virtual machine managers will have different requirements, and this also depends on the amount of hosts that you'll be supporting within that software. If you look here, I have an older system from Microsoft, Virtual Machine Manager 2007, and this shows what types of requirements you need if you have 5 to 10 hosts, or if you have 11 to 20 hosts. And you can see the recommended processor is about the same, but the RAM goes up and the hard drive space goes up. Now, newer systems will need even more. Hyper-V recommends that you have even more memory available per guest operating system. If we take a look at Windows 10 Hyper-V, we'll see that you can easily find out if you meet the Hyper-V requirements by typing systeminfo.exe, and we'll do that later in the lesson. And you can see here the VM monitor mode extensions, the firmware needs to be enabled, the second level address translation, and DEP or data execution prevention. All these have to say yes for you to run Hyper-V. So you want to check that before you actually do that on a Windows 8.1 or 10 system. So different requirements depending on the amount of hosts, and it's different based on which program you use. A Type 2 hypervisor or a Type 2 VMM such as VirtualBox won't have as much as far as resource requirements as, say, Hyper-V for Windows Server 2012. Then there's the network requirements. And you need to make sure that your virtual machine manager can work with your network card, your network adapter on your system, because not all network adapters are compliant with virtualization software. So you want to make sure the virtual network adapter is compatible with your VMM. And then as a general rule of thumb, you want to make sure that you have 20 megabits per second per virtual machine as a bare minimum. for that connectivity through the network, because you can throttle this by the virtual machine if you need to. And you want to have more than that if high data transfer or multimedia is involved. But generally, I like to go with 20 megabits per second as connectivity for one particular guy as just a basic connection. Now, if you're going to be transferring video or what have you, then that number is going to get a lot higher. So you're going to want to check this on your systems and verify that you have the amount of bandwidth that you need, 20 megabits per second per VM as a bare minimum. And then also you can calculate the typical amount of data that will be transferred. You might have a server system or a powerful Linux system running as a virtual machine, or you might have a separate Windows 10 system running as a virtual machine that has to constantly move data back and forth. And you want to think about how long it takes to move that data. For example, if you have 10 gigabytes of data, that will take approximately 2 minutes on a 1 gigabit per second network if the entire channel is available. But if you have other guest operating systems, then you want to make sure that you're calculating properly. You're going to have to divvy up the total bandwidth, the total network throughput amongst the different guest operating systems and the hosts that are using that system, the physical hosts that are using that system. So you want to think about those network requirements. And if we go over here to VMware, VMware has a page where you can calculate the bandwidth requirements for vSphere and for other types of virtual machines that you might use with them. And it really gets into depth with that. And so you want to take into account your link speed. You want to take into account what type of hardware you're using, how many hosts there are on the physical side and on the virtual side. And put that all together to think about, okay, what are our network requirements? Do we need a new switch? Do we need a new router to control all these virtual machines that'll be sending data? How much data will the virtual machines be sending? And finally, for the hosting computer or computers that are running the virtual machine manager software, again, make sure the virtual network adapter is compatible with that software. Next is security requirements. The security of the virtual machine should be similar to the physical host security. So the actual PC or server that you have, the physical box, is going to have a certain level of security. You want to make sure that that device is secure, but also the security of the virtual machines running inside of that guy, they should be similar to that security or equivalent to that of the physical machine's operating system. The virtual machine should be updated to the latest patches, the latest service pack, whatever version of Windows it is, the latest updates. If you have multiple virtual machines, especially ones that are going to interact with each other, you make sure that they're updated in the same manner. They should be at the same point release of the operating system or the same service pack. And that ensures patch compatibility between the virtual machines. The virtual machine should have the latest antivirus definitions. Perhaps it should have a firewall enabled. It should have strong passwords, all of the security that you would do with a regular physical host. And we'll be talking more about security as we move on through the course. But there are a lot of other things to watch for that, if not addressed, could really cause problems with your virtual machines and even your hosting computer. So first, you want to make sure you update that virtual machine software. If you're running VirtualBox or if you're running Hyper-V or you're running VMware, you want to make sure that guy is updated because that's going to patch some security holes and have it perform better with the latest OSs within the virtual system. Configure any applicable security settings and options within that virtual machine software as well. Watch out for network shares within the virtual machine. You might have network shares between the virtual machine and the physical computer or between two virtual machines. And by default, malicious software and attacks cannot travel between one virtual machine and another. But if you create a network share between the two, malware and attacks could easily go from one system to the other. So you have to be careful with network shares. If a network share is needed, map it, then use it, and then disconnect it when you're finished. And document where those network shares are. If you're done with it, you should just disconnect it. Or better yet, when you set up the mapped network drive in Windows, you'll see that option reconnect at logon. And just go ahead and deselect that. This way, when you log off and log back on or restart the virtual machine, that mapped network drive will be gone. So watch out for mapped network drives. Disable any unnecessary hardware. And you could do this from within the virtual machine. Optical drives, USB ports. If there's any type of removable media that you need to use, enable the device, make use of it, and then disable it immediately afterwards. Now, you can disable these devices within the OS, the virtual OS, say within the device manager, but quite often devices can also be disabled within the virtual machine manager software as well. And if you have a virtual BIOS or UEFI, check the boot priority and make sure that it's set to hard drive first, just like you would with a physical computer. Limit the resources a virtual machine can use. A compromised virtual machine can be a threat in the form of a denial of service attack, but if you limit the amount of resources, especially on the network side of things, you could eliminate that possibility. And you want to throttle this network activity. To mitigate this, you could just set a limit on the amount of resources any particular virtual machine can utilize. The better the hypervisor, the better the virtual machine manager, the more power you'll have with this. So if you're using Hyper-V or VMware, you can easily throttle this. Also, periodically monitor the usage of the virtual machine. But you want to be careful with monitoring. Enable it only for authorized users, admins, and disable the monitoring whenever it's not necessary. Next, protect the raw virtual machine files. The virtual machine is just one big file. It's almost, you could consider it an image, a file on the hard drive. So you want to protect that raw virtual disk file, because if something was to go wrong with that file, the whole virtual machine is gone. So look into setting permissions for who can access the folder where the VM files are stored. And if your virtual machine software supports logging or auditing, consider implementing that and see exactly who started or stopped the virtual machine and when. Otherwise, in Windows, you can audit the folder where the VM files are located. And finally, you can make a copy of the virtual machine file. Every once in a while, you should back it up, make a snapshot of that guy. You can also encrypt the disk file and digitally sign it and validate that signature prior to usage. And last comment, protect the hosting computer as well. The virtual machine should be as secure as possible, but it's only as secure as the hosting computer that's in the controlling position, the computer that's running the VMM software. So harden that computer and then harden the virtual machines in a similar manner. Let's show a quick example of a virtualization program. This is Oracle VirtualBox, and this is the VirtualBox Manager. This is the virtual machine manager software. This is a type 2 hypervisor. It runs within the operating system. It's not bare bones, but it's good for my purposes for training, and it's good for testing. So this works pretty well. But if you're going to have systems in production, then you want to have a type 1 hypervisor of some sort. And you can see the list of virtual machines that I'm running here. I have Ubuntu. I've got Windows Server 2012. I've got an old version of Windows XP just in case a question comes up on it. Windows 7, Windows 10, Windows 8. Everything is here, and all of these are separate virtual machine files, but they're all stored in the same place on a drive. So you got to be careful with this. You want to make sure that you protect those files. And then you can see the settings for each of these. You can see the amount of memory that I've assigned to the virtual machine. And you can see how much video memory it's using. You can find out information about the audio, the network, the USB. If we were to click on one and then go to settings, we'd get even more information about this. Where the file is stored, how much memory we're using, which we can modify here. The boot order, as I mentioned before, make sure that hard disk is first in the list. Chipset compatibility, the mouse or pointing device that you're using, additional features, for example, EFI, which we definitely would want to enable on, say, Windows Vista or higher and some other operating systems. There's tons of stuff here to look at as far as what you're doing with the system. Audio, network, serial ports, USB. And again, if you're not going to use something like USB on this system, then disable it altogether right from here. Just get rid of it. No need to go ahead and disable it in the device manager within the virtual machine operating system, because we've disabled it right here from the virtual machine manager. So that could be very powerful, more higher level control. Shared folders, we mentioned this can be deadly when it comes to malware and when it comes to attacks. So monitor these shared folders within here as well. So you can see all this stuff from here. And this is just a very basic example of a virtualization program, but something that you can download for free. So I would say go and check out the latest version of VirtualBox, download it, and you could download Ubuntu for free, and there's plenty of other types of Linux you could download for free. Install that directly to a virtual machine and see how it works. And we'll show a little bit more with this and other virtual machine manager software programs in the last sub-lesson of this lesson. So that's about it for this one. Again, make sure that you're checking your requirements, your network requirements, your system requirements, and your security requirements, and make sure that they will all work with the software you want to run within the virtual machine, and make sure that your hosting computer can support all this as well.